Hello, geometry students. Mrs. Fallon back here. What I'm going to talk about today is sine and cosine. So we did a little bit of the trig, right? So we talked about tangent, and so now what we're going to get into is dealing with sine and cosine ratios. All right, so I like this just because it kind of rounds out everything you were doing with tangent, and now you kind of have the whole gamut. These are the only three trig ratios that we're going to learn this year. When you do your unit in Honors Algebra 2 next year or Algebra 2 next year, you'll kind of be introduced to some reciprocal functions, which end up being, very similar to what we're doing here, but we just don't get into them in geometry. All right, so I'm actually on page 264 of your student journals. If you want to go ahead and join me. All right, you might have heard of this whole concept of Sohcahtoa. And so I'm going to have you write it down and then I'll explain it. So, S-O-H, and I put a little bar in between, ka, C, and then A-H, and then toa, Sohcahtoa. So it's a little, way to help us remember our trig ratios. So we've already talked about tangent. So what tangent is the ratio of opposite side over adjacent side. And so we're going to add to it the so and the ka, which is your sine, which is opposite over hypotenuse, your cosine, which is adjacent over hypotenuse. So again, thinking back to what we understand these ratios are representing, they're representing the ratio of side lengths. So this is the ratio of the opposite, so the opposite leg, and I'll show you how to kind of do that, over the hypotenuse. So if you remember, tangent didn't really deal with the hypotenuse. Tangent dealt with just the opposite leg and the adjacent leg. Cosine is the ratio, so again, that just means fraction, of your adjacent leg over your hypotenuse. So if we were to draw a triangle, so let me draw one right here, a little right triangle, let's label it. So here's a right triangle, it doesn't really matter what kind we have. And so what I would get at here is if we have an angle like theta. So again, remember, theta is one of your acute angles in your triangle. It can be up here, doesn't really matter. So I'm gonna place it down here for now. If theta's here, then the side opposite is over here, right? The side adjacent, or the leg that's adjacent, would be right here because it's next to. So again, it kind of shares a leg. It shares kind of part of that angle. And then of course your hypotenuse, there we go. Your hypotenuse is always across from your right angle. So what we're getting at here is that sine of an angle. So again, you can't just have sine by itself. It doesn't make sense. Sine is an operation. Sine tells you what you're doing to this angle. So what I'm doing to this angle is I'm saying I'm taking the sine of it, which is the ratio of the opposite side to the hypotenuse. And so what you will generally see is us kind of abbreviate to be O over H. And then cosine would be your adjacent over H, or A over H. And then again, just to kind of reiterate that tangent was our opposite over adjacent. So now we have all three kind of trig functions done and kind of accounted for. And we're going to do some examples with all three of them. So before I get into that though, let's chat a little bit about this angle of depression. I think I talked about this in the last one, but just kind of want to review. A lot of times what we'll talk about is like, an angle of depression. Remember I was telling you about like the tree, and you're kind of, trying to figure out how tall the tree is. So you put a string at the top and you kind of have this right triangle formed, right? So just to kind of remember that if this is our theta, okay, we call this right here our angle of elevation. I'm just going to write it kind of small, but it says angle of elevation. And again, that's kind of this small acute angle that forms with the ground or the bottom or whatever it is that we're talking about in this particular problem. The angle of depression is always kind of outside of your right triangle. So this up here is your angle of depression. So remember, it's not this little acute angle that's inside of your triangle. It's outside of the triangle. So this is your angle of depression. Again, fun fact, remember that the angle of depression and angle of elevation, because this horizontal line is parallel to that horizontal line, these are alternate interior angles, a little blast from first semester. And so because we know that when lines are parallel, alternate interior angles are congruent. So if I tell you the angle of depression is 12 degrees, then I'm also kind of telling you that the angle of elevation is 12 degrees. So they go hand in hand. So just make sure that you kind of understand that kind of concept. All right, let's do a few problems so that you can kind of get a feel for what it is that I'm going to ask that you do with the sine and cosine and tangent stuff. All right, let's draw a right triangle. I'm just going to draw this one. I'm going to call this A, B, C, and then I'm going to give you some side lengths. So I'm going to do 36, 39, and 15. All right, so one of the common questions would be something like, write your sine, cosine, or tangent ratios for the acute angles in your triangle. So that what that means is like you would find sine of angle A. You would also find cosine of angle A if I was asking you for both. Then if I wanted to figure out the other acute angle, I would do sine of angle B and cosine of angle B. Now, of course, we could also add tangent to the mix, but since we've already talked about tangent, we'll just kind of focus on sine and cosine. So be careful here that you remember that, we're talking about two different angles in this diagram, right? So if angle A is kind of where I'm starting, remember that sine is opposite over hypotenuse. Remember that whole Sohcahtoa thing. So the opposite side to A is 15, and the hypotenuse side is 39. So I'm going to label this with an H because that's going to stay put regardless of whether I'm talking about angle A or angle B. The only thing that changes when I change angle B is that my opposite and adjacent switch sides. So in other words, I'm going to say opposite side is 15, my hypotenuse side is 39. You always want to reduce your answer. So 15 over 39, you can reduce this by 3, so you get 5/13. Don't leave it as a decimal, leave it as a fraction, it's more accurate, but leave it as a reduced fraction. All right, cosine of A is adjacent over hypotenuse. So if the side length that's next to or adjacent to angle A is 36 degrees, not 36 degrees, 36, and our hypotenuse is 39. So again, let's reduce this. I'm going to go ahead and reduce it by 3, so I get 12 over 13. All right, so let's switch gears. Let's do the sine. So sine now of B. So now we're talking about B. So now my opposite side would be 36. My hypotenuse stays put at 39. You will notice that those are just, so sine of B and cosine of A are the exact same thing. And then you can probably guess that cosine of B and sine of A are going to be the exact same thing. So cosine of B is 15 over 39, adjacent over hypotenuse. And again, that reduces to 5 over 13. All right, let's do a couple other things. So let's go on to page 265. So what we're talking about here is like the complementary angle. So that was just kind of what I was getting at, that like the sine of angle A. So if I did sine of angle A, so let's say A and B, the sine of angle A would be this side over this side, is the same thing as saying the cosine of angle B. So the sine of one angle, acute angle, is the same as the cosine of the other angle. And vice versa. The cosine of angle A is the same thing as the sine of angle B. So that's what this up here is all saying. They're just saying that the sine is equal to the cosine of the other angle. So sine of A is equal to cosine of B, sine of A is equal to, or cosine of A is equal to sine of B, and so forth. So that's what that's getting at. So you might see, an example that will say, write cosine of 69 degrees in terms of sine. So what they're getting at here is, like, let's say I gave you let's draw a little triangle here. And let's say I know that this angle is 69 degrees. Doesn't matter which way I put it. Doesn't matter if I put it down here or up here. But what you do know is that if I do the cosine of this angle, that should equal the sine of the other angle. So cosine of 69 should equal sine of this other angle. You can figure out this other angle, right? We have enough information to do that. If we know this is 90 and this is 69, then there's only 21 degrees left over for that angle. So what I'm getting at is sine of 21 is equal to cosine of 69. And a nice way to kind of double check is to use your calculator, right? So if I did sine of 21 degrees, make sure you're in degree mode, and cosine of 69, notice I get the exact same ratio, the exact same. So what I'm getting here is a ratio of side lengths, and I get the same thing. So that's what this is saying about, is just kind of understanding that how cosine and sine are related. All right, let's do some extra practice. All right, so I'm gonna do as many as I can on this, and then we'll kind of circle back around to see how you guys are doing. All right, so it says find sine of f, sine of g, cosine of f, cosine of g. Write each answer as a fraction and as a decimal rounded to 4 decimal places. I'm going to actually not do the whole 4 decimal places thing. If you want to, you can. I just don't feel like it, and I don't feel like it's super necessary. So what I'm going to do is I'm going to go ahead and do number 1. So number 1, if I had to do sine of f, sine of g, cosine of f, cosine of g. So that's what I'm asking you to do. It's kind of find 4 specific ratios. All right, so sine of f, here's f. Opposite, hypotenuse. So I would get 12 over 13. So again, if you remember the relationship, sine of f is the same thing as saying cosine of g. So like this would be the same answer. All right, let's do sine of g. Sine of g would be opposite, which is 5 over hypotenuse. So 5 over 13. And so again, sine of this angle is going to equal the same thing as cosine of the other angle. So cosine of this should be 5 over 13. Now you can always just kind of do the cosine angles, right? Cosine of angle F is adjacent over hypotenuse. That's how I got 5/13. Cosine of angle G is adjacent, which is 12 over hypotenuse. And so that's what they're asking you to do here. All right, this one says, write the expression in terms of cosine. So this is what we were doing above, okay? So you can use kind of this formula if you want, or you can think of it in terms of a triangle, which I, to be honest with you, think it's a little bit easier to think of it in terms of a triangle. So what I was getting at is if you know this angle is 9 degrees, what do we know about this angle here? Well, if this is 90, then these two angles have to add up to 90. So I would do 90 minus 8 or 90 minus 9 and get 81 degrees. So what they're asking you to do here is say sine of 9 degrees is equal to the cosine of the other degree. So in this case, sine of 9 degrees is equal to cosine of 81. Now you can use your formula if you like. I don't prefer to use that. So what they're saying here is if I did sine of 9 degrees, it would equal cosine of 90 minus 9 degrees. So there, I'm just kind of plugging it in here. Sine of 9 degrees is equal to cosine of 90 minus my 9 degree angle. I like to think of it in terms of a triangle. Let's do number 5. So number 5, I'm just going to kind of write it up here. So it's a 30-degree angle. So again, doesn't really matter where you put it, but sine of 30 degrees. So if I would say sine of 30 degrees is going to equal cosine of this angle here. So what is that angle? Well, if this is 30, then this has to be 60. So that would have to be a true sentence. And then sine of 77, I'll have you try on your own, and then I'll circle back around and give you answers at the end. All right, let's try a few more on the next page, which is page 266. So this one is doing the exact opposite. Write your expressions in terms of sine. Again, if you think of it as a triangle, and you're given one angle, figure out the other angle. So all I do here is take 90 minus 15 and get 75. So I would say cosine of 15 degrees is equal to sine of the other angle. So sine of 75. Cosine of 15 is equal to sine of 75. Same thing with the cosine of 83. Let's move the 83 up here this time, doesn't matter. Figure out what's left over for this one, which would be 7. So I could write cosine of 83 degrees would be equal to the same thing as saying sine of 7 degrees. So I'll let you try number 9 kind of on your own. And that way, when we're done with the video, I'll kind of circle back and give you answers. All right, so this is using our trig ratios to set up and solve. This is kind of the bulk of what I want you to be able to do, okay? So this is kind of the main point here, if you will. All right, so let's go over exactly what I'm gonna ask that you are able to do and show work for. So you're gonna be given an angle, right? So in this case, I got this little acute angle here is 16. You need to solve for x and you need to solve for y. So pick a variable to start with. And it really, honestly, most of the time doesn't matter which one. A lot of times people just start with x because it's, alphabetical. So in relationship to this angle, x is my opposite side, right? It's across. Y is my adjacent and 9 is my hypotenuse. So if I am going to solve for x, okay, I don't know what this is, but I have this angle. I do know the hypotenuse. I don't know adjacent sides. So I'm going to use a piece of information that I already know. So for example, I'm going to say sine of 16. So sine of 16 degrees. And the reason I'm picking sine and not cosine or tangent is because sine deals with opposite, which I'm trying to find, and the hypotenuse, which I already know. So x over 9. So sine deals with opposite over hypotenuse. So I picked sine on purpose because I wanted to solve for x. This is where solving those proportions comes in handy. So cross multiply, x equals, and then the rest of this is you're doing your calculator. So you're going to do sine of 16 times 9. Let me show you what that would look like. Sine of 16. Don't forget to close your parenthesis here, otherwise you'll get the wrong answer. So sine of 16 times 9, I get 2.48. So it asks you to round to the nearest tenth, so I guess we'll round it to 2.5. Okay, that's x. Let's do similar work, but let's solve for y. So again, similar idea. Here I have 16. This time I want to figure out my adjacent side, and I'm already given my hypotenuse side. So which trig function deals with adjacent and hypotenuse? Well, that's cosine. So if I take cosine of my angle, I would do adjacent side over hypotenuse. So y over 9. Same deal, let's cross multiply. So I'm going to do cosine of 16. Whoops, not 116. Cosine of 16. Close my parenthesis, times it by 9. I get 8.7 if I round it. All right, I'm going to do one more with you, and then we'll see about having you guys do. So I'll have you guys do 11 and 12. I'm sorry, 11 and 13, and I will do number 12 here next. All right, so number 12, let's take a look at what we have. Here is a 47-degree angle. This is my opposite side, this is my adjacent side, this is my hypotenuse. So I would start by labeling your triangle so you kind of know what you're dealing with. So what do you want to solve for first? Well, maybe you want to solve for C, okay? So that's what I'm going to go for. I don't know my hypotenuse, but I do know my adjacent side. So if I know I'm going to solve for C, and I'm given my adjacent side. So which trig function deals with opposite and adjacent? Well, this is where that tangent is going to come into play. So I'm going to do tangent of 47 is equal to opposite over adjacent. So C over 10. There are other options of how to simplify or solve for these. I'm just really giving you one. All right, let's cross multiply. So tangent of 7, close your parentheses, times 10. I get to the nearest tenth, 10.7. Okay. Let's solve for D this time. I'm going to squeeze it in over here. Hopefully you can figure it out. All right, so in my triangle, I was already given my adjacent side. I tend to use the side lengths that I was already provided. The reason why is I don't really want to use C because I rounded this answer. And not that that's bad, it's just that it's not going to be as accurate. So when given a choice, always start with use the numbers that are provided for you in the diagram. So in this case, if I want to solve for D and I'm given my adjacent side, you have to ask yourself, well, adjacent and hypotenuse. Which trig function deals with adjacent and hypotenuse? Well, that's cosine. So you would do cosine of your angle is adjacent over hypotenuse. So this one's a little different. Notice where the variable is on the bottom. So cross multiply, you would get d times cosine of 47 equals 10. So think about what you would have to do in order to solve for d. Remember, cosine of 47 is just a number, so it's not like it's a variable or anything. So what I would do here is divide both sides by cosine of 47. So if I take 10, so this is what it would look like, 10 divided by cosine of 47, and that's it. So when I solve this, I get 14.7 as my hypotenuse. So this is kind of the bulk of what we're going to be doing. So we're going to be doing some more practice with this, but I would like you to try 11 and 13, and that way you can see if you're on the right track. Let's do a couple story problems. In fact, let's do one, and then I'll have you do one. I'll do A and you can do B. And again, kind of same deal. You can kind of check your answers. All right, so it says a camera attached to a kite is filming the damage caused by a brush fire in a closed off area. The camera is directly above the center of the closed off area. A person is standing 100 feet away from the center of the closed off area, and the angle of depression from the camera to the person flying the kite is 25 degrees. How long is the string on the kite? All right, so there's this closed off area, right? We'll call it X. Whatever. I'll star. I don't really care. And then there's this kite that has a camera attached to it. Okay, I'm not an artist, so understand that. So there's my kite. And then this is the closed off area. It says you're standing 100 feet away. So this is where, you're standing right there. That's you. And it says the angle of depression from the camera. So again, we're kind of we're drawing a triangle here. Remember, this whole unit's about triangles. So you're drawing a triangle. So we're kind of looking at this relationship here where we have like the height above, we have this distance here. It says the angle of depression from the camera to the person is 25 degrees. So remember what angle of depression was. So imagine you're kind of going straight horizontal out. Your angle of depression is this angle here. Again, not the little acute angle in the triangle. So this angle is 12 degrees. Okay, again, why is that important? We know the angle of depression and the angle of elevation, which is this angle right here, are congruent because of alternate interior angles. So let's label the angle of elevation as 25 degrees. So really, the only reason why we're giving you this information is so that you can find that information. Our goal is to figure out the height here. So I am going to, the angle of elevation, how long is the string? We're not doing this. We're actually figuring out how long the string is. So the string is attached from the kite to the person. So that's what we're trying out, which is the hypotenuse. All right, take inventory of what you're provided and then decide which trig function you're going to use. All right, so here's my angle. So it's 25 degrees. This 100 is my adjacent side to that angle. And what we're trying to find is my hypotenuse. So again, think about what trig function deals with adjacent and hypotenuse. So if you think about Sohcahtoa, A over H will be your cosine. So cosine of your angle is equal to adjacent over hypotenuse. And so that's going to be your equation that you're going to set up. All right, cross multiply. And then divide both sides by cosine of 25. So let me do that. 100 divided by cosine of 25, and I get, it doesn't say how much to round it to, but we did tenths before, so we'll stick with tenths. So 110.3, and we're talking about feet. So let's label it. All right, let's see if you can do the second one on your own, and then, like I said, I'll circle back around, and we can do those, at least give you the answers. All right, I'm going to give you 2 extra examples. I know that you're probably not super excited about that, but that's okay. So I'm going to give you 2 extra examples of some other problems that you would see involving some of these trig ratios, okay? So grab a sheet of paper. You can pause the video if you need to go grab some, but this is kind of just some bonus questions. All right, first example says, which ratios are equal to root 2 over 2. Sorry, I'm just trying to read that and do that at the same time. So I'm going to give you a triangle. And I'm going to tell you this, this, and this. So what I'm asking you to do here is I'm asking you which of our trig ratios, so sine, well, I should probably, let's call this A, B, or C. So sine of A, cosine of A, tangent of A. Let's do all of our acute angles. And then let's do sine of B, cosine of B, and tangent of B. So what I'm asking you for is which of our trig ratios, so I'm going to kind of combine the special right triangle stuff that we did with kind of just using sine, cosine, and tangent. All right, so this is what I'm asking for. Do you recognize that this is a 45, 45, 90 triangle? If you didn't, recognize the fact that those two side lengths are the same. And I forgot to put in my right angle, but that's a right angle. If these two sides are the same, these angles have to be 45 degrees in here, okay? So knowing that, you should be able to come up with our side lengths over here. So remember what we do to get from a hypotenuse back to a leg of a 45, 45, 90 triangle. We divide by root 2. Divide by root 2, let's rationalize. So I get 9 root 2 over 2. And again, we know that both those sides are the same since they're marked as congruent. So again, I just multiplied the top and bottom by root 2 over root 2. I just didn't show my work here. And it reduced to 9 root 2 over 2. All right, so I'm looking to see which ones are equivalent to root 2 over 2. So let's do sine of A. So sine of A is 9 root 2 over 2. That's my opposite side over hypotenuse. So 9 root 2 over 2 divided by 9. So you have to do a little math here, okay? How are you with multiplying fractions and dividing fractions? Hopefully okay. So what you did here is if you divide fractions, remember you're change it to multiplication and flipping the second fraction. Flip the guy and multiply, I think is how I remembered it. Anyways, you would cancel out the 9s, and so if you reduce, multiply across the top, multiply across the bottom, I get root 2 over 2. So I know sine is equal to root 2 over 2. You should already know that cosine of B will also be root 2 over 2. And the reason why is because sine of one angle is equal to the cosine of the other. Okay? So just something to kind of consider. So I already know that this one is going to be root 2 over 2. All right, let's look at cosine of A. So the interesting part about this is that since these side lengths are all the same, like adjacent and hypotenuse are the same, cosine of A would be the same ratio as I did here, 9 root 2 over 2 divided by 9. So rather than doing the work, I'm just going to kind of rewrite the answer, right? So it's the same ratio. Cosine of A is adjacent over hypotenuse. So I get root 2 over 2, which means this one kind of satisfies this equation. Likewise, if cosine of A is equal to sine of B, then this one works. So it looks like all of our sine and cosine ratios are all going to equal root 2 over 2. All right, let's do tangent. So tangent is opposite over adjacent. So tangent of A. Opposite side is 9 root 2 over 2 divided by 9 root 2 over 2. Well, when you divide something by itself, like 1 divided by 1, 100 divided by 100, 9 root 2 over 2 divided by 9 root 2 over 2, what do you get? 1. You get 1. And then if I did tangent of B, opposite over adjacent, notice that the same exact side lengths, this would equal 1 as well. So tangent of A and B are not equal to root 2 over 2, but all of the sine and cosine ones are. Let's do another example with the 30, 60, 90 triangle. So same kind of deal. So I'm going to give you that this is 60. I'm going to call this M, N, and P. And I'm going to give you that this is 2 and this is a right angle. So this time I want to know is, I want ratios that are equal to root 3 over 2. So again, you're looking at, the ratios I'm having you look at are sine of A, sine of M, cosine of M, tangent of M. I'm just going to kind of put all those together. and then sine of P, cosine of P, and tangent of P. Okay, so those are the ratios we're going to be looking at. So let's fill in our side lengths. So this is a reminder of, our special right triangles. This is our long leg because it's across from the larger angle. We know that that's a 30-degree angle because the 30 and the 60 have to add up to 90, which is my short leg and my hypotenuse. From hypotenuse back to short leg, we divide by 2. So that gives me 1. From the short leg to the long leg, I multiply by root 3. So 1 times root 3 is root 3. All right, let's do our ratios. Sine of m. Here's m. Sine is opposite over hypotenuse. So I get root 3 over 2. Looks like that one met the criteria, so I'm good to go here. Also remember that sine of m is equal to the cosine of p. So that means this one has to be the same exact thing. All right, cosine of m. Cosine of m is 1 over 2. Okay, that obviously does not equal root 3 over 2. And then cosine of m is equal to sine of p, which is 1/2. So I'm not going to circle those because they don't equal root 3 over 2. All right, tangent. Tangent of m is opposite over adjacent, which would be root 3 over 1 or root 3. And that one's not equal. And then tangent of p would be 1 over root 3, which again, we would have to rationalize to root 3 over 3. So there's only 2 ratios here that would be equivalent to root 3 over 2. All right, I'm going to go back and give you answers to the ones that we missed on the extra practice. So if you want to pause the video and go try those and then come back, that would be amazing. All right, so for those of you who are with me, I'm going to go back to page 265 and just kind of give you answers to all of these problems. So on number 2, you had to find, sine, cosine, all those ones. So sine of f, I got to be 65 over 97. Cosine of f, I got to be 72 over 97. And then sine of g, I got to be 72 over 97. And cosine of f, I got, cosine of g, I got to be 65 over 97. For number 3, I got sine of f to equal root 2 over 2. Sine of g to equal root 2 over 2. Cosine of f to equal root 2 over 2. And cosine of g to equal root 2 over 2. For number 6, sine of 77. So the way I thought of this was if that was 77, then this had to be 13. So sine of 77 is equal to cosine of 13. All right, let's go on to the next page, which is page 266. And let's do the ones that we missed. So that was number 9. So cosine of 45. Again, if you look at a triangle, if this is 45, this angle actually has to be 45 as well. So cosine of 45 is going to equal the same thing as sine of 45. Number 11, I used this angle and I said this was my hypotenuse and this was my opposite and this was my adjacent. So to solve for m, I did adjacent over hypotenuse. So I did cosine of 72 is equal to m over 50, and I got m to equal 15.5. For n, I did sine, because it was opposite over hypotenuse, so I did sine of 72 is equal to n over 50, and I got n to equal 47.6. For number 13, this was my angle, so this is opposite, hypotenuse, adjacent. So to figure out A, I did adjacent over opposite. Well, actually, I'm going to do opposite over adjacent because that was tangent, because I want hypotenuse here. So tangent of 65 is opposite over adjacent, so it's 28 over A. So again, if you cross multiply, you would get this, and I got A to equal 13.1. All right, to figure out B, I could do opposite over hypotenuse. So I'm going to do sine of 65 is opposite, which is 28, over B. So I cross multiply, I get B times sine of 65 equals 28. And so B is going to equal 30.9. And that's what I came up with. All right, for the story problem at the bottom, it says the string is a kite. So they're actually basically the same diagram. You know, here's my kites. Here's the, whatever, the part that was, says the string of the kite is 200 feet. How far away must a person fly the kite, stand from the center of the closed off, assuming the same angle of depression of 25 degrees. All right, so kind of same deal. They're asking you for, like, you know, they're asking you to find a different piece of the puzzle, right? So they're saying, what is this distance? If this is where you're standing, how far am I standing away from this center? If the kite is 200 feet long and the angle of depression, which is also our angle of elevation, is 25 degrees. So so in relationship to this 25, I did this length here is my adjacent side, and this length here would be my hypotenuse. So I did cosine. So I did cosine of 25 is adjacent over hypotenuse. And I got to be 181.3 feet. So that means you're standing 181.3 feet if the cord or the string on the kite is 200 feet long. All right, that's all for now. I know this was a long video. Go ahead and practice. This is definitely going to be important stuff. So make sure that you're able to do this. Any questions, bring them to class. All right, bye for now.